Good evening. Today I will discuss another numerical on the reactions. Now this type load means types of trapezium type load. Intensity is 800 Newton per meter. Here this is 1600 Newton per meter. इस लोड को आप दो पार्ट में तोड़ सकते हैं. यहाँ से आप एक लाइन ड्रॉ करिए. This will be treated as UDL and this will be treated as UVL, यानी uniformly distributed load, uniformly varying load. इसके ऊपर हमने एक न्यूमेरिकल सॉल्व किया था कि इसको कैसे ट्रीट करते हैं. तो टोटल लोड ड्यू टू UDL यानी A, B, C, E पार्ट के लिए जैसा आपको बताया था कि इसकी टोटल इंटेंसिटी है आपकी 800 न्यूटन मीटर, बिकॉज दिस इज 1600 एंड दिस इज 800. दिस इज लाइन पैरेलल टू दिस, दैट मीन्स अप टू दिस विल बी 800 न्यूटन पर मीटर, राइट. सो 800 इंटू लेंथ ऑफ डिस्ट्रीब्यूशन 4000 न्यूटन and it will act at midpoint as discussed in the previous numerical. Now for this is uniformly varying load, since this was 1600 and this is 800, so this will be 800. 1600 minus 800, this will be 800 shown here. So total load due to UVL, area of this triangle 1/2, 5 and multiplied by 800. Actually this is maximum intensity at this point. So this is 2000 Newton, right. Now as discussed here, if this is UVL and this distance is x, means length of distribution is x, then from zero intensity end it will act at 2/3 of x, 2/3 of x, and from maximum intensity end this is 1/3 of x, where x is length of distribution, right. So now this is free body diagram here. 4000 at midpoint, right, and this is due to this uniformly distributing load. So this will be at midpoint, means this is 5 meter, so 2.5 meter from this end and 2.5 meter from this end, right. 4000. Now this is 2000 Newton calculated here. This is this uniformly varying load, and as I told you 1/3 of x from maximum intensity end. So this is maximum intensity end, right. From this 1/3 of 5, this will be 1.67 meter, and 2/3 of zero intensity end like this 2/3 of x means 2/3 of 5, so this will be 3.33 meter, right. So this load is of 4000 Newton at midpoint, 2000, 1.67 meter from this end and 3.33 meter from this end, right. Now as usual we will apply the conditions of equilibrium. So here Ra plus sigma Fy is equal to 0, right. Upward force positive, downward force negative. Ra positive, this 4000 downward minus 4000 minus 2000, this one, and plus Rb, this is upward, is equal to 0. From here Ra plus Rb is equal to 6000. This is equation number 1. Now we will take moment about point A, right. Clockwise movement is positive, anti-clockwise is negative. So movement of this force and reaction about this point will be 0, because perpendicular distance will be 0. Now movement of this 4000, this is situation, right. So this is force about point A, so this will try to rotate in clockwise direction, so positive. What is movement? Force into perpendicular distance. So force 4000, distance is 2.5 meter from this point. Again 2000, similarly movement will be in clockwise direction. So 2000 distance is 3.3 from here to here, 3.33 meter, right? RV is in upward direction, so its movement about A, anti-clockwise, and it will be considered negative. So minus RV into 5 is equal to 0. On solving, RB is equal to this 3332 Newton. Actually here we have rounded it, right? Otherwise it may be 3.333. So some value may change there. On solving this, now put this value in equation number this on putting. So RA is equal to 6000 minus RV, 6000 minus this value 2668 Newton. So RA is equal to 2668 Newton, right? These values are rounded here. So what is new in this question? How we will deal the uniformly varying load. इस तरह से आप इसको पॉइंट लोड में कन्वर्ट कर सकते हैं. ट्राइंगल का एरिया लीजिए और जीरो इंटेंसिटी एंड से 2/3 ऑफ टोटल डिस्टेंस एंड मैक्सिमम इंटेंसिटी एंड से 1/3 ऑफ टोटल डिस्टेंस, राइट. थैंक यू.